Hi everyone, I am Neeraj. I am studying in grade 8 in Lekol Chempaka, Trivandrum. Today I am going to be explaining about the light in our lives. Let's go and see them. So first let me introduce about light. Light is a type of electromagnetic radiation that moves through space. It is a small part of the electromagnetic spectrum and radiation given off by stars like the sun. Animals such as humans have eyes sensitive to light to see and understand the world around them. Light normally travels in straight line rays and reflects and refracts in very precise ways as it speeds through the world. The study of light is called optics. Next, we will look at different sources of light. First is the natural source of light, which includes the sun, stars, lightning, glowworms, fireflies, jellyfish, etc. The next source of light is the artificial source of light, which includes the torch, light bulbs, candlelight, flames by matches, lasers, lights from TV and mobile phones when they are turned on. Next, we will look at the properties of light. There are 7 basic properties of light. They are reflection, refraction, diffraction, interference, polarization, dispersion and scattering. Let's look at them one by one. Reflection of light. When a ray of light falls on a smooth and polished surface, for example a mirror, light returns back in the same medium. This is called reflection. Now let me explain this diagram. When a light ray falls on this polished surface mirror, it's called the incident ray. When it gets reflected back from the mirror, it's called the reflected ray. The angle between normal and the incident ray is called the angle of incidence, and the angle between the reflected ray and the normal is called the angle of reflection. Now there are some laws of reflection. Let's see them. The incident ray, the reflected ray and the normal ray at the point of incidence lie in the same plane. The angle of incidence is equal to the angle of reflection. That is, angle I is equal to angle R. Applications of reflection of light. In side view mirrors of cars. The side view mirrors of cars are made up of a convex mirror. When rays of light strike the surface of the mirror, it bounces back and helps the driver to see the objects on the sides and behind the car. In microscopes. A metallurgical microscope or reflected light microscope is used to see the objects that do not transmit light and are opaque. These microscopes use the phenomenon of reflection to see the objects. In telescopes, a reflecting telescope is used to see celestial objects. It consists of a combination of 2 mirrors and an eyepiece. When rays of light strike the surface of the concave mirror, it gets reflected and falls on the surface of the flat mirror. The flat mirror further reflects the incident rays of light to the eyepiece. This enables the astronomer to view celestial objects. Now let's look at the refraction of light. The bending of light as it passes from one transparent substance into another, which is caused by the change in speed. This is called refraction of light. When light enters a denser substance, which has higher refractive index, it bends more towards the normal line. In this figure, we can see an incident ray. When it comes to substance 1, it gets refracted in substance 2 and bends towards the normal. This is called refraction. Now the amount of bending depends on 2 things, the change in speed and the angle of the incident ray. If a substance causes the light to speed up or slow down more, it will refract or bend more. If the light is entering the substance at a greater angle, the amount of refraction will also be more noticeable. On the other hand, if the light is entering the new substance from straight on at 90 degrees to the surface, the light will still slow down, but it won't change direction at all. Refractive index, also called the index of refraction, measure the bending of a ray of light when passing from one medium to another. Refractive index is also equal to the velocity of light c of a given wavelength in empty space divided by its velocity v in a substance, or n equals c by v. Let's see some applications of refraction of light. In human eyes. Human eyes have a lens known as cornea. It works to refract light onto the retina. The image is then sent through your optic nerve to the brain. Without refraction, you wouldn't be able to see. In lenses of glasses. The lenses of glasses or contacts are made up of a plastic that purposefully bends the light specific ways. This is used to improve vision. In lens of a telescope or microscope. The lens of a telescope or a microscope uses a refraction of light to make things look closer than they really are. The lenses of the telescope and microscope are curved in such a way that they magnify small objects or those far away so the human eye can see them. Cameras capture images by refraction. When you click the shutter, an image is refracted onto a light-sensitive surface, giving a snapshot of your birthday party. Manipulating refraction and the speed of light creates some very interesting shots. Interference of light. Interference is the phenomenon in which two waves superpose to form the resultant wave of the lower, higher, or same amplitude. In optical testing, interference is used in testing surface quality like flat surface, spherical surface, roughness of surface, etc. For example, when you look at your CD, you can see a rainbow pattern. This same happens when you look at a soap film or a thin film of oil floating on still water. This effect is produced because of interference of light waves hitting the CD surface or soap or oil films. Now let us look at the diffraction of light. Diffraction is the slightest bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of light to the size of the opening. The reddish appearance of the sun during sunset or sunrise is due to diffraction. Sun appears red because light gets diffracted due to a dust particle in the atmosphere. Light through a shadow of an object is also a real-life example of diffraction. X-ray is an electromagnetic wave, and this wave has a very helpful application from taking X-rays of the human body to find some minor defects in bones, to find the structure of a material. Dispersion and scattering of lights. Scattering of light is the phenomenon in which light rays get deviated from its straight path on striking an object like dust or gas molecules, water vapors, etc. The colors we see in the sky are due to the scattering of light. In this diagram, we can see that an incident light, when it strikes a surface, it gets scattered from the object. When white light is passed through a glass prism, it splits into a spectrum of colors in order: violet, indigo, blue, green, yellow, orange, and red. And this process of white light splitting into its constituent colors is termed as dispersion. In this figure, we can see when a white light is passed through a glass prism, it gives out and disperses the 7 colors of a rainbow. Now let us look at optics and its history. Optics is the branch of science that studies the behavior and properties of light, including its interactions with matter and the construction of instruments that use or detect it. Originally, the term optics was only used in relation to the eye and vision. Later, as lenses and other devices for aiding vision began to be developed, these were naturally called optical instruments, and the term optics eventually became broadened to cover any application of light, such as a photographic plate or a television camera. In the 20th century, optical methods came to be applied extensively to regions of the electromagnetic radiation spectrum not visible to the eye, such as X-rays, ultraviolet, infrared, and microwave radio waves are included in the general field of optics. Thank you and have a nice day.